Hey everyone, welcome back to the Android app development series where we are going to be building a dad joke application where it will just display random dad jokes from an API. If you haven't watched the first video in the series and you don't have Android Studio set up, I would strongly encourage you to go back and watch that one. We also covered all of the different dependencies that we are going to be using, so we updated our Gradle file to include things like Moshi, RxJava, Retrofit, Dagger, Mock, all those good things. We probably are not going to revisit the Gradle file too often. There might be some things that were missed, but if you haven't watched the first video in the series, I would strongly encourage you go back and check that one out. So in this video today, we are actually going to create the entire dad joke application. We're going to do this in a very rough way. It's not going to be perfectly architected. We are primarily going to have the application set up for Retrofit and parsing the response with Moshi and then displaying the dad joke. So first up, let's take a look at the actual API that we are going to be using. So this is iCanHasDadJoke.com, and you can see they have a dad joke right here, and you can generate new ones. You can keep clicking new. So we are going to essentially rebuild this sort of experience on an Android device. So what we want to look at first, though, is down here they have the API. And if we go through the API documentation, we can see that there is no authentication required. There are API response formats, so we will use the accept headers. So if we don't provide anything, it'll just give us back plain text. If we ask for JSON, it will give us JSON as the response. And if we ask for text plain, it will just give us plain old text. Now, if we are making requests via curl and we don't provide an accept header, it will just give us text plain by default. They also ask for this custom user agent, so it helps them better monitor the usage of their APIs. So we will be actually setting a custom header for that. And then from there, they also provide us different endpoints. So if we just want to get a random joke, all you do is just say, here is their website, and then it will retrieve the joke for you. So this is actually essentially the response that we are going to be creating. They also give you the ability to fetch a dad joke by ID, to fetch one with an image, to search for dad jokes. So we can kind of expand on this app further in the series once we get the basics set up and everything like that. But for now, we will head on over to Android Studio and just make sure that our base curl request is going to work and make sense. So back over here in Android Studio, if we open up Terminal, which is a part of Android Studio, which is kind of nice. It should be fairly platform agnostic, whether you're on Mac OS, Linux, Windows, whatever. And if we paste in the base curl request, you can see that we get the dad joke back. I clearly copied way too much of the request though, so whoops, just really just need to copy the top portion. The bottom portion is the example response that you would get back. But the other one is for the custom user agent. So I want to make sure that we set that correctly as well. And so if we paste that, well, they want us to do a user agent like this. So we delete this. My coding series. And since this is for a YouTube series, I will just paste the URL there. Oh, looks like it did not want to do that. Let's try that one more time. So there we go. So that should work. Paste that in. It looks like we are still able to get the response that we're looking for. Everything's looking good. So for now, I'm just going to copy this and then doing Command-Shift-A, I'm going to type scratch to create a new scratch file, and then it'll just be a text scratch file. And this is just a way to take notes of the different things that we will be doing. This way I just don't have to switch windows quite as much. So we'll move that over to the right, and now we can start building our application. So for that, if we do Command and then click on main activity, we will be brought to our main activity. Alternatively, you can navigate to the resource folder, layout, and main activity will get you there as well. So this one I'm going to move over onto this side of the screen as well. And you can see by default it gives us the GUI or the WYSIWYG rather, for creating our layout. And you can see over here there is a component tree, and it's a constraint layout with the text view. And over here you can set a bunch of different attributes. So this is one way that you can edit the layouts. They also give you all sorts of like text, button, widgets, your own layouts, containers, Google specific views, so like an add view or a map view, and then some legacy views which have since been essentially deprecated. Although you will probably still find relative layouts laying around. Hopefully you won't be seeing too many of the other ones in projects though. What I like to do though for when I'm developing applications is, instead of being in this design tab, I like to click on text, and then over on this side there is a preview tab. And if you're not seeing that, sometimes it will be removed, and so you'll have to do tools and then those toolbars. So as you can see, if the toolbar windows is unchecked, you will not see them. Sometimes Android Studio, either you'll maybe hit the wrong hotkey or maybe it's just a bug, but it will disable this. So if you ever don't see them, just come up to views, go to toolbar or tool windows bar, right? Yeah, tool window bars, and they'll pop right back up. So now for this one, we're going to do all of our editing in XML. It just ends up going a bit quicker once you get used to it. So I think it's better just to kind of like rip that band-aid off and just start from the XML. But if you are ever wondering or want to avoid the XML, there is still that design tab. So now we are going to modify our default layout. So this is where we will have our dad joke as well as a button to give us that random one. So if we go back here and just look at that for a reference, we have a button to give us a new joke, and then we have the actual random joke right there. All right, so we're going to keep our constraint layout here. The constraint layout is the newest like root layout. It's a container layout that allows you to have child views within them. But the neat thing with the constraint layout is it handles all of the calculations for where the view should be in a single level. So before, you would either have to have a bunch of linear layouts or relative layouts, and you had a lot of performance concerns. So I won't go over all of the details of a constraint layout, but the main thing to keep in mind or to remember is the constraint layout is almost always going to be one of the most performant options that you have. Linear layout will still make sense in some cases. There is a chance that we will have some linear layouts over the course of this series, but for today, in this video, we should be able to get by with just using the constraint layout. So what I'm going to do is I'm going to delete this text view that we had by default, and I'm going to do a new app compat text view. The reason why I'm going with the app compat version is this is the support version. This will give you backwards compatibility with other versions of Android. If you use the regular text view, you're essentially just getting whatever text view was shipped on that device. So I prefer just going with the app compat text view and the app compat version of pretty much everything. You'll notice the constraint layout doesn't have that. It's shipped as its own library, so you don't have to worry about it. But yeah, the app compat versions will usually give you a bit better backwards compatibility. And so we can go ahead and set this up. So the layout width, we want it to be match parent, which, as you can see over here, the preview shows that its constraints have updated to be the full width. And then for the height, just wrap content, which will say the height of the view should be whatever height it needs to be to fill it. And then I'm just going to do the forward slash, and that will complete that. And then you'll see there's now a warning. This view is not constrained vertically. At runtime, it will jump to the top unless you add a vertical constraint. All right, so let's go ahead and do that then. So the vertical constraint that we're looking for is going to be something like app, and then, so this layout constraint is going to be the one that we're looking for. So we say layout constrained, or constraint. So if we do end to end of, it'll constrain it to the end of that. What we want is constraint top to top of, and then we can just say parent. There are other options, so you can say constrain to an ID, which would be another layout that is within the constraint layout. But for this one, we're just going to constrain it to the parent, and that removes the warning that we got. The other thing that we can do though is we can also constrain this to the, so we do layout constraint start to start of and parent. It'll constrain it to that side. And then if we do app layout constraint end to end of and parent, it'll constrain it to that side. So now the anchor points for this view, you have it constrained to the start, the end, and the top. We don't constrain it to the bottom, so it can grow as it needs to. And then because of that, we can actually update our layout width to be 0 dp. So dp would be density independent pixels. These allow you to scale up or down. My cat is freaking out. I don't know why. But anyway, these allow you to scale up or down based on the PPI of the device, so how dense the pixels are. You typically want to use DP. I don't even know if, okay, so it will still let you use pixels, but don't. Just use DP. All right, and then the last thing that we're going to do for this layout, at least for right now, is we are going to do a app compat button, and we're going to tell its width, we'll do 0 dp for it. Its height, we're going to do wrap content, and then do that. And then you'll see again, it will jump at runtime. So for this one, we want to constrain this button to be, well, we could do it below the text view, or we could do it constrained to the parent. I think we're going to do it constrained to the text view though, just to show you the alternative way. So constraining things to a layout ID. So in order to do that, we need to give our app compat text view a layout ID. So we'll do that by doing Android ID equals ID, and this will just be dad joke text. And then for our button, we will do app layout constraint top, and then to bottom of. So it will be the top of our button will be constrained to the bottom of whichever view we do. And in this case, it will be the ID dad joke text, and then we'll do app layout constraint start to start of parent, and then same thing, layout constraint end to end of parent. And then we will also assign this one a ID. If we don't, we won't have a way of referencing the button later in our main activity. So we'll just go ahead and do that now and say generate button. And then you might be looking at this wondering, what does the view look like? I mean, as you can see over here, it's just a couple different widgets and things like that. So let's go over here. We will copy this dad joke, and then we're going to add the text to it. So in order to display that text, all we will do is say tools, and then you'll see there's this one that says adds tools namespace to Android XML file. So go ahead, hit enter to do that. And then this, we will actually cut that and then move it up to here, which for some reason we already have it there. Alrighty. So tools, and then if we do text equals, and then paste in the dad joke, which I guess I should recopy. We'll go ahead and remove those quotes for now. And then we'll add a new line to that, just because that's what it looks like I wanted. And the nice thing about using tools is this text will only appear in the layout editor. So when you launch the application, it will not display the text. Whereas if you did Android text, you'll see you even get a warning saying that hard-coded string, you should use the string resource instead. But if you go ahead and use tools, it's completely fine. This is strictly just for the layout editor. And then the last thing that we'll do is for our button, we actually want to use a hard-coded value. Well, not necessarily hard-coded, but we're going to use a value that will persist even in the app. So for that, we do Android text equals, and we'll say generate new joke. You'll see over here, hard-coded string. If we do option enter to extract the string resource, it will ask us, what do you want to name it? We'll say generate new joke is fine for the resource name. We'll click OK. And then if we open up our strings XML, so again, strings XML will be in the values. So res, values, strings. And all of these values, what they allow you to do is to translate them. So that is why you want to have all of your hard-coded strings in the strings XML file, because it allows you to then translate them into multiple different languages. So with that, we can go ahead and close the strings XML. We'll go ahead and minimize the preview because we don't need to look at this anymore. And then we can move this window all the way over there. And then we can refocus on the main activity and start adding in the actual logic for generating the dad jokes. All right, so now that we are over in our main activity, we can start wiring up the views. So for that, we are going to reference the dad joke text. So we can do that by doing dad joke text, hitting enter. And you'll notice up here, let me go ahead and zoom in a bit. Up here, it will say Kotlin X Android synthetic main activity main. So what this is it's part of Kotlin X. It is a library that allows you to do all of your view bindings in a very simplistic way. And what I mean by that is, so we have the dad joke text, and then we can say text equals, this is just a test. Whereas the old way, or the way that you would do it traditionally in Android, if you were doing this in Java as opposed to Kotlin, is you would have to do find view by ID. And what that looks like is we would do find view by ID. It would be a app compat text view. I would say r.id dot, and it would be our dad joke text. And then from there we could say text equals, this is with find view by ID. Now, there are some trade-offs that you'll get by using the synthetic version. We're not going to worry about those in this video. Truthfully, a lot of times it's much quicker, and for that, if you start running into issues where this synthetic version is not working for you, you can always revert back to find view by ID or use some other library to do that. So I just thought it would be worth showing what it looks like, calling out that there are going to be some potential trade-offs that you'll get, but we aren't going to worry about those for this video. The next thing that we want to do though is wire up our generate button. So if we type generate button dot set text, or sorry, not set text, set on click listener, it'll give you a couple of options. The one that we're going to go with is the second one though, that just has the curly braces. And you'll see that for here, it'll pass in a view. So we can say view. And the view that it passes in is going to be the generate button view. For this, we don't really care though. We can actually ignore it. So, and then it'll actually say redundant lambda arrow. And so we'll just remove the arrow. We'll go back to what it was previously. And for this set on click listener, what we want to do is we want to actually set the text. So just to kind of have a general example out there, we're going to say over here, private var counter equals 0. Every time that this is clicked, we're going to do counter plus plus, and then we are going to say dad joke text dot text equals clicked, and then $sign counter. For this one, we will delete it, which I will just do command delete and get rid of that. And then over here, if you already have the AVD running, great. If you don't, you can go and find the AVD manager, run it, get the emulator set up, and then over here just click the run button. It'll take a little bit to go through the Gradle build process, but once it's there, we should see the dad joke app pop up, and then we can test it out, make sure that everything is looking okay. All right, so you can see the emulator popped up now. I was allowing the train to pass by before coming back to show you what this looks like. So now we do generate new joke. If we click on it, we'll see clicked 1, 2, 3, 4, and it'll just keep counting. Of course, though, we're not building an app to count the number of times that you clicked on something. We are building an app to display dad jokes from an API. So this is where we now get into using things like Retrofit and Moshi. So let's hop over here real quick and search for Retrofit. And we'll select the square library, allow another train to go by. And then you can see right here, it gives you a sample of how you would build the default version or a sample version of a Retrofit instance. So what I like to do is, just so I can reference everything, I'll copy this over, move over here, and for our scratch file, which has our network information, do a couple new lines, paste that in, and over here we will also copy this service. We'll paste that above. And the nice thing about this is you can just easily reference everything instead of having to switch from one screen to another. So you can keep that open. And what I'm going to do is, like I said before, this is not going to be the way that you would build an Android app and ship it to production. We're going to be refactoring in future videos to show you test-driven development, how you use Dagger, all of that. This is strictly just this video. We are going to have an app that pulls from an API with Retrofit and display those results to you. So for that, we're going to create our interface, which will be just interface dad joke service. And for retrofit, you have these things called annotations over here. What an annotation is it's letting the compiler know how to generate code for you. And so for that, we'll just do git. And I believe actually for the dad joke API, because it doesn't actually have anything, I'm going to just assume that the value will just do that brace. Or actually, we'll try and leave this blank and we'll see how that works. Truthfully, I have not used retrofit in a situation where you don't have any like URL parameters, where you just hit the base URL. But I'm pretty sure we will find a way to get past that. So with that, we will then do, for this one, the name of the function is going to be fun get random dad joke. And then for now, we will have it return a call. That call will be a single object. That single object needs to be in the shape of the random dad joke. So if we go back over here, look at the example of a response, copy that over, let the train go by, and then we'll just paste that example right there. So dad joke will give us a ID, which looks to be a string, a joke, which also is a string, and a status, which looks like it's just an integer. So for that, we are going to create a data class. We will call it dad joke response. And if you're wondering, what a data class is, anything like that, I would strongly encourage you watch my Kotlin tutorial series where we go through all of that more in depth. But for the data class, we're going to have a val, and we're going to have ID, which will be a string. We will then have val joke, which will be a string, and then val status, which will be an int. Let the train go by. I think rush hour is almost done, and the trains will hopefully stop going by soon. So we will let this one also pass, though. Living by the CTA, it has its pros, it has its cons. This would be one of the cons. All right, so we have our dad joke response. The call is going to return a dad joke response. From there, we should be in good shape. So now over here, what we want to do is we are going to get rid of our counter, get rid of that, and then we're going to do a private val dad joke service by lazy. So we're going to initialize it lazily, and then for that we will have our retrofit builder. So over here, if I zoom in a bit more on that, you can see our retrofit builder. I'll zoom in a little bit more on here, and we will say retrofit.builder. Let's import that with option enter. We will give it a base URL, and that base URL will be coming from here. So it has dad joke. And we can call build on that. And then for here, we will call create. We will pass in the dad joke service. And it's saying it wants a class. So for that, we'll do : class. And it's probably going to complain that it's not Java. So .java, so the Java class instead of the Kotlin class. And then from here, so we have our dad joke service. We have our set on click listener. What we want to do is dad joke service dot get random dad joke. And then you'll see it gives us a couple different options. So there is an execute, which will return a response there's an enqueue, which we use a callback with. So for this one, we're going to do enqueue on. And for that, since it's looking for the callback, we'll do object : callback dad joke response. We'll import that callback. We'll be doing a new instance, or actually, so we'll have curly braces there. It's going to say that we need to implement some members. So we do that. We'll implement on failure, on response. And then the only thing that we're going to do now is, so if there's a failure, we will do log.d, and it's looking for a tag. So the tag is going to be how we will identify what is displayed. So, and you'll see that in just a second, the actual like output. But for now, just do private. So we do private val tag, and we'll do this class dot name, simple name. And we're going to say that it will never be null, just because it most likely never will be null. If it is null, we have other problems. We'll say tag, and then from here we will say error t dot message. And then if the dad joke was successful, for now we're just going to do log d tag success, and then provide it with the response. So if all goes to plan, if everything works like we hope it does, this should, in theory, work, and we shall see. So let's go ahead and run the app now. And then what we want to do is open up logcat down here in the bottom, let the train go by, and we'll switch this over to debug. It'll give us a little bit less information than if we had verbose. And the tag that we're looking for is just going to be main activity. And so we can see a couple things have been output for that. Over here, we'll just do the trash can to delete it. We'll clear out the logs. We'll come over here. We'll click generate new joke. Hopefully it works. Otherwise, we get to do some debugging. So we do generate. App crashes. So, and that is fine. And so we can see over here that the get URL, so missing either get URL or URL param. And for that, I wonder if it would be just enough. So it looks like it's coming from here. If we were to do that, just add that ending right there. Go ahead and run it. So it's now running. We do generate. Shoot, it is still crashing. Is it crashing for the same thing? Nope. So we can see now it is crashing for something new. So previously it was crashing because get cannot be empty. Typically it will not be empty, but for the dad joke API, it's so simple. It makes things a little bit weirder for this example. But anyway, I digress. So we're now crashing for an illegal argument exception. Unable to create converter class Cody Engel dad joke response. So this is because actually up here we're not specifying the way that you would convert the JSON response to this dad joke response. And so this is where Moshi is going to come in. So if we go over here, and then there's Retrofit, and they have converters. So they have the different converter options, and so Moshi is the one that we're using, and they give you the documentation that when you're building out the Retrofit builder, you want to add your converter factory. So let's hop over here, back in our dad joke service section. Before we call build, we're going to do add converter factory, and then this one is going to be a Moshi version of it, and so that one will be Moshi converter factory, and then .create, and this should create it with a base instance. So I do command click to look at the decompiled code, the source code for it, and we can see that create will just call the other create, passing in Moshi builder build. If you need to do more complex JSON parsing or mapping, you would want to actually call the one where you provide your own Moshi instance. In this case, though, we don't. We're good. Adding this converter factory should, in theory, be all that we need. So we go ahead, we run it again. Third time is hopefully a charm. We do generate dad joke. Third time clearly was not a charm. Or actually, was it? Hold on. Let me rerun this. Let me just make sure, because I'm not seeing anything. Generate new joke. We're not seeing anything. Run. What are you crashing on now? Of course. So while I would love to say that I planned this out, I actually, like, last night I was thinking I should plan out this missing internet permission, because it's essentially the way that you always have your app crash. But alas, I did not. I completely forgot. So with Android, you do have to provide permissions. Usually you provide the permission once in your manifest, and then you forget about it until you create a new app, and then you try to run the app and you see that it crashes. So if we go over to our Android manifest, and again, if you're not using hotkeys, you go to project, app, manifests, Android manifests will get you there as well. So a bunch of yellow. We're going to ignore the yellow. And then what we want to do for our permissions is say uses permission. And then these are all of the different permissions that you can define. For us, we're crashing because we're not saying that our app requires the internet permission. So now that we add that to our manifest file, if we go rerun our app for a fourth, I guess technically a fifth time, generate the new dad joke, you can see it did not crash. That's good. If we go to logcat and then collapse that one, we will see operation not permitted. So this is likely because if you remember back to our curl request and the dad joke, the way it works is it will default to not being JSON. And so this is likely failing because it's trying to parse the response that we get back to a dad joke, but we're not saying that we're expecting it to be JSON. So I believe we have a header option. It's been a little while since I've added headers with Retrofit though, so I just want to consult the documentation, and we can see here there's headers. There's also, you can provide an array of headers. For this, since we want to use that custom user agent, we will go ahead and use this version of it. I'm just going to copy this over. Again, just as that point of reference for what we want to do. Paste that there, and then we say headers, and it will take an array of headers. And for that one, we have the first one is going to be our accept, and for accept we want it to be application JSON. We'll do a comma. We want it to be our custom user agent, again, just because the API maintainers have requested that we provide that. So for mine, I'm just going to do this custom one. For you, it might be a good idea just to do your own custom one. And so I'm going to say Android tutorial, like, comment, subscribe. And then you'll see this is in red. All right, so that was a lot of hassle for not a whole lot of, yeah. Anyway, so our headers, we now are just defining it as the value. It appears that the value with the triple dots is doing it as a var arg. I was thinking they wanted us to pass it in as an array. It definitely looked like an array, but I guess not. So now anyway, if we go ahead and we run it, we should see that when we do generate, we should get a log. So at this point, I would much rather just set some breakpoints. We'll go over here, run with the debugger. We will see why exactly, why are you not working? What is wrong? And we'll do generate the new dad joke. We get down here to this. This evaluate will allow us to take a look a little bit more at the failure reason. So if we do T, look at that. We get socket exception, socket failed. Look through here, real connection, thread pool, because, let's see, tries to do that real call. All right, so what we're going to do instead is, let's see. So we already have our dad joke service, get random dad joke. If we do, well, we will not do that because the instance died. So at this point, it's probably better just to go on over to Google, take a look at why that is happening. So let me just go ahead, run the app again, just so I can get that error message. We will take a look at that. So this one, we are getting this error message. And by the way, let me know if you enjoy this with these tutorials. If like me live coding, going through all the pain of errors and things like that, if this is helpful or if this is distracting, because if you do enjoy this, I would love to make the majority of my other videos very similar to this one. If you don't enjoy it though, I would like to do a little bit more prep work, have just the base application there, and then it's just me kind of recoding everything. So with that though, we're back on Stack Overflow, we're looking at the issues. Someone solved it by uninstalling the app from the emulator and running it again. So we'll go ahead, we'll kill that. We will long press on the icon here, do app info, uninstall. We will see if that fixes it. It would make me feel better if it fixes it, because it means that everything is set up as it should be, and it was just some weird setup. But do generate, and hey, all right, it's working. So always great when all you have to do is uninstall an app and reinstall it to make it work. Can't say my problems as of recent with Android development have ever been that, but cool. So we get this though, we get the response, we get the message, all of that good stuff. So, but you'll notice that this isn't the actual response of the joke itself. This is just the base response information. So what we would want to do to get the response itself is to do body. So if we go rerun it one more time, do generate new joke, we'll see dad joke response with a joke and all of that. All right, so cool. This is shaping up quite nicely. What we want to do now is, this isn't very helpful. If you do generate dad joke and you just keep generating them, you should ideally see them, right? So let's go ahead. We have our log statement there. For the error situation, we will just do our dad joke text.text. Oops, an error occurred. Please try again. Otherwise, if it was successful, we'll do dad joke text.text, and then we will do the response.body. And if it ends up being null, which hopefully it's not, actually hold on. So we'll do response body dot joke. If that's null, we'll just do oops, no joke was received. Please try again. Sure. And then we'll go ahead, rerun the app. You'll notice that this is also yellow. It's saying that the string literal set text cannot be translated. Use Android resources instead. So we'll get to that in just a second. But first, let's see. Generate new joke. So we have that, and we have that. Look at that. look at all those dad jokes coming through. So, this is great. We're going to clean this up just a little bit, and then I want to actually go back and add RxJava, because while it's nice that you can do enqueue on this, it would be even nicer if we could use RxJava operators to further streamline all of this. So first though, let's clean this up. It's saying that this cannot be translated. So we will do extract string resource again, and then we'll say error dad joke API. Well, let's do that. That's essentially what it's doing. And then you'll see it auto-completes for us. It says get string error dad joke API. We should do a similar one though for this. Even though it's not warning us, it is the same exact concept. So since we can't extract it, we will go to our strings file. And again, you go to app, resource, values, strings, or use the hotkey. And by the way, for the hotkeys, this one, it again would be Command Shift O, and then you can just type in strings or Command Enter in strings. This is for Mac OS though. For Windows and Linux, I can't quite give you the exact hotkeys, so that's why I am trying to just give you that other option there. But anyway, again, I digress. We will now create our string name error dad joke not found, and then instead of not was no joke was, we'll do oops, we could not find that dad joke, please try again. Copy that, go over here, and then the same thing, just call get string r.string error dad joke. And just in case you're wondering, what is this R? So this is your resource, and it doesn't give you that anymore. Cool. So r.class. This is a generated class for you that is generated from your project. So you get a bunch of different constants, a bunch of random things, and essentially never edit it. Never even, at this point, as you can see, Android won't even let you look at it. It'll just take you to the resource that it thinks you're looking for. But that's essentially what R ends up being. It's just a generated class for you. You have strings, you have images, things like that. So again, though, I digress. The last thing that we need to do for this project is get it set up with RxJava. So RxJava allows you to manage your multi-threading or manage threads a little bit nicer. It also allows you to do concurrent programming in a more sane way. So right now with this enqueue, every time we call enqueue, we have to have an on failure and on response, and then we end up having all of these things nested. And so while this isn't a big deal for one random dad joke, if you had to do multiple network calls to create a single response, you'd have to do get the dad joke. All right. If it was successful over here, then get the next thing that you're looking for that response. If there was an error, make sure you handle that error correctly. And it ends up just getting very messy. So that is why we are going to use RxJava. Retrofit, let's see if it has the adapter already. It does not. So in that case, over here, we'll go to their GitHub project. We'll come down here and find the adapters. And you'll see there is a RxJava call factory adapter. So we will go ahead and add that next. All right, so we can go ahead for the call adapter factory. We're going to want to copy this over. So again, we go back over here. We have a converter factory. We want to add a call adapter factory. And this one will be our RxJava 2 adapter factory dot create. And now I just want to kind of show you the flexibility of this, because we can go ahead, we can run it, even though we have the call adapter factory for RxJava, we can generate a new dad joke and it will still work. So the nice thing about this is if you didn't have a call adapter factory to start off, and then you wanted to add one later on, you can add that call adapter factory, but then still have your old jokes show up. So now for this one, we can do fun and say single random dad joke, and it will be a single. This is a RxJava type. We'll say dad joke response. And then I'm just going to copy those over, paste those in. And for this, I'm going to comment this out because we no longer care about that. And then we are going to do dad joke service dot single random dad joke. And this will give us a single response. As soon as it's complete, it will tear itself down. Don't have to worry about it. There are other RxJava operators like observable, flowable, completable, all of those. And we'll get into some of those in a future video. So once we get into persisting the dad jokes, we're actually going to change things up to be most likely a flowable for us. And we'll kind of show how that works. But for the purposes of this video, we're just going to worry about singles. They return a single response, very similar to how this enqueue is working. And then for that, we're going to do subscribe. And we're doing this knowing, or me knowing anyway, that it will break. It is going to crash. Can almost guarantee it. We're going to go with this subscribe option that is a lambda that has two parameters. So the first one is going to be response. The second one is going to be an error. And what we can do is check, oops, I also misspelled error. So if error does not equal null, we want to do this. So I'll uncomment this for a second just so I can paste that in. And we'll say error.message, display that. We'll then do else. So our response, we will uncomment this just so we can copy that. And then we have the success. And we can say response. And you'll notice in this case, we don't have to do response.body anymore. That is because with RxJava, if it encounters a networking error or anything like that, it'll propagate that to this error. So let the train go by. So up here with the call that we got back, this is how we can kind of interrogate the response that we were getting to know, well, why did the error occur? What actually happened? In this case, if we get the error, we will know that, you know, the response code could have been like a 403, it could have been the 500, whatever. It'll still propagate to the same exact spot, and we'll know that. And that's why this response, so we don't have to call body anymore. We just have to do response joke, and if the joke wasn't found, do that. We go ahead and run the app, and we will go ahead and generate the new joke. Again, it should crash. Or not crash, sorry. It'll give us that oops, an error occurred because we're accounting for this error situation. But nonetheless, we're getting an error back. Why are we getting an error? Why is that happening? Well, from this message, it does not look very hopeful as to why we're getting that error. So I'll set a breakpoint real quick just to see, but and you go up here and you use this debug icon, and it'll attach the debugger to your existing process. If you ever need to just run it with debugging on without attaching it to the current app, you would just do this debug app. But anyway, again, I digress. We have our debugger attached. We'll do generate new joke. We get an error. I go over here to the evaluate expression. And then we do, well, why why did we get an error? What was the reason? And we see that the exception reason is network on main thread exception, which is what I was expecting. So what this was doing for us over here, the vanilla retrofit way, is NQ was running all of this on a background thread for us, and then it was resuming on our main thread. So with Android, you have a concept of a main thread, which is where all of your UI operations have to happen. And then you have another concept of a background thread where you would want all of your network calls, all of your long lasting or long things that take a long time to actually operate should happen on the background thread. Ideally, everything that is not UI related, though, should happen on the background thread, which is a nice thing with RxJava is you can actually defer a lot of things to that background thread. The downside is it does take a little bit of extra setup work. And so for that, we will do dot subscribe on, and then schedulers. So you have a computation or an IO thread. You have other ones as well, but for the purpose of this, we're going to use IO. This is for operations that are doing input, output. They're things where if you do a network call, you're going to make that request, and then you're probably going to be waiting for a little bit of time. So there's going to be downtime where the thread isn't doing any work. Whereas computation is when you're doing something like maybe generating a bunch of prime numbers. That's going to keep that thread locked up for the entire time that you're doing that. So in our case, for network calls, we want to use the IO scheduler. We go ahead, we run the app, and at this point, I believe the app should actually crash, and it's going to be because we are trying to update this on a background thread. We're going to try to update the text widget on a background thread, but I just want to show this just as a general example, just so you know what it looks like if you forget to set something up. So we're over here in our emulator. We do generate new joke. Surprisingly, I don't know why, it is allowing this to work. Strange. So my only assumption is that we're creating this on the main thread. We're creating this observable, this single on a main thread. And so just so I can kind of show an example then, if we create a new thread, we do run, and over here we delete this. And the main reason why I'm doing this is we want to set this up so that we end up observing on the main thread at all times. So we go ahead, we run it. This should trigger a background thread. We run it, the app crashes. Cool. That is what I was expecting. And so the error that you get is the exception cannot be delivered. Consumer has already been canceled, disposed. Over here, only the original thread that created a view hierarchy can touch its views. So when you see this error in Android, what that is a signal for is you're trying to update a view off of the main thread, because the main thread is the only thing that is going to create a view hierarchy, or at least it should be. So what we have to do though is for this is do observe on. So everything that happens in our subscribe block, everything that we're observing on from this stream above needs to happen on the main thread. And so we actually don't have what we need. What we need to do is make sure that we are importing the correct value in our Gradle file. So if we go to Gradle, we find the one for app. It will look like this over here. We have our different implementations, and we are going to need to add another RxJava import, or RxJava dependency. So we search for RxJava 2 in all of GitHub. Actually, I believe it's just going to be RxJava Android in all of GitHub. We have ReactiveX, we have RxAndroid. And then over here we have these different options. So we have implementation, And so it's because our Android releases are few and far between, it's recommended you also explicitly depend on RxJava's latest version. All right, cool. So we'll go with that. We come over here, we add our, so we have RxJava there. If we add that guy, and then say convert to G-string, we resync our project. Let me just make sure that this is correct version. Yeah. 2.1.1 is the version we want. Come over to here, and actually let's just, sorry for switching back and forth so much. What we want to do is we have this Android schedulers dot main thread. So we do that one, Android schedulers dot main thread. We go ahead, we run the application, even though this thread is even though this is happening on a background thread, we should still force it to observe on all updates on the main thread. So go ahead, generate a new joke. You see that it works, and you'll see it's kind of doing some weird stuff for us though. It looks like it's generating multiple jokes. Likely an issue because we have this thread like this. So that, I think, is realistically a good stopping point. We're going to delete that, clean this up. This get random dad joke, we're not using it anymore, so I'm going to do a safe delete there, and we will delete those unused imports. So that is all we have for this video. Just to kind of summarize what we went through though, we talked about how you would actually create a retrofit instance that could hit an API. We showed you the vanilla way of using retrofit. We then showed you the way that you could do it with RxJava. We talked about views. We set up a very plain, very vanilla, very boring looking view. And we did a lot of debugging in between. So in our next video, I intend to talk about how we would do this in a test-driven development sort of a way. And in order for test-driven development to work, we have to break up this main activity into using a Android view model, which will make it much easier to test. We will need to pass in retrofit as a dependency. We will need to account for the fact that this random joke is happening on a different thread, and because of that, it will be inherently more difficult to test. And yeah, it should be overall a pretty good, pretty substantial video that we will go through. So with that, thank you so much for watching. If you made it to the end, that is awesome. If you enjoyed the video, which I hope you did, be sure to give it a thumbs up. If you're not subscribed already, click the subscribe button. If you want to be notified when I upload new videos, click the notification bell. But otherwise, my only question to you again is, did you enjoy this format of video? This is likely the format I'm going to do for the rest of this Android series, but I do want to know, should I stick with this format where I'm showing you kind of the debugging that goes through, just like truly building a project up from scratch, or would you rather see a little bit more upfront work where I actually build up the project, I know what works, and then I'm just sort of typing things out saying like mechanically this is what you do. So let me know in the comments. I would really appreciate it. Thank you so much for watching though, and I will catch you in the next one.